There is a region on Mars, roughly the size of Australia, that rises high above the surface of the planet. 3 of the largest volcanoes in the solar system line up to guard its western flank. To the east, a vast canyon, 6 to 7 times deeper than the Grand Canyon, cuts into the barren Martian plain. This strange region, once so baffling to scientists, recalls the planet's violent past. A time long ago when the planet's core erupted, pushing molten rock to the surface. It's part of a larger story, a planetary tragedy, in which Mars began its descent into the cold, dry, and lifeless state that we see today. We are now scouring its surprisingly complex surface for clues to the events that long ago doomed the red planet Mars. Since the early 1960s, we've tried 46 times to send spacecraft to Mars. Across the 55 million kilometers of its closest approach to Earth. Over half failed at launch or upon arrival. The rest flew around the planet, snapping pictures, recording data. Or they landed to test its soil and rocks, and crawl around its canyons and craters. These probes may one day pave the way for human explorers, who will dig deeper still in search of answers to our most pressing question. Did Mars, at some point long ago, develop far enough for life to arise? If so, does anything still live within Mars' dusty plains, beneath its ice caps, or somewhere underground? Mars does not give up its secrets easily. Over the years, that has led observers on this planet to jump to all sorts of conclusions. In the year 1877, the Italian astronomer Giovanni Schiaparelli noted markings on Mars' surface, a latticework of lines. He called them canali in Italian, meaning channels in English. Schiaparelli began to sketch them and name them, connecting them in a vast global network. Over a 15-year period, beginning in 1894, the American astronomer Percival Lowell closely examined these features. He saw a remarkable drama unfolding on our neighboring planet. In his view, Schiaparelli's channels were artificial canals designed perhaps to carry melting snow from the poles to the dry interior. After all, on Earth, the Suez Canal had been open since 1869. Construction on the Panama Canal had just gotten underway. The Martian canals, Lowell surmised, had been built by a sophisticated society confronting an environmental catastrophe on the grandest of scales. Its inhabitants faced an urgent choice: move water across vast arid regions or perish on an increasingly dry planet. In a series of 3 best-selling books, Lowell took his case to the public. The public responded, with some ideas of their own. With the means to remake an entire planet, perhaps these Martians were more advanced than humans. Some of us began offering schemes for making contact. Giant mirrors to flash greetings. Light beams. Mental telepathy. Lowell's vision fell by the wayside in 1964. The Mariner 4 spacecraft flew by Mars and got a good look. What it saw looked more like the Moon than the Earth. 3 more mariners followed. These missions documented a heavily cratered landscape, pocked with huge dormant volcanoes, and cut with the deepest and longest canyon in the solar system. They saw no traces of life, present or past. Then, in the mid-1970s, 2 lander-orbiter robot teams, named Viking, went in for an even closer look. The landers tested the soil for the chemical residues of life. All the evidence from Viking told us Mars is dead and extremely harsh. The mission recorded Martian surface temperatures from -17 degrees Celsius down to -107. We now know it can get even colder than that at the poles. The atmosphere is 95% carbon dioxide, with only traces of oxygen. And it's extremely thin, with less than 1% of the surface pressure of Earth's atmosphere. And it's bone dry. In fact, the Sahara Desert is a rainforest compared to Mars, where water vapor is a trace gas in the atmosphere. On Earth, impact craters erode over time from wind and water, and even volcanic activity. On Mars, they can linger for billions of years. Earth's surface is shaped and reshaped by the horizontal movement of plates that make up its crust, driven by heat welling up from the planet's hot interior. At half the width and only 11% the mass of Earth, Mars doesn't generate enough heat to support wide-scale plate tectonics. Nor does it have the gravity to hold a thick atmosphere needed to store enough heat at the surface to allow liquid water to flow. Nonetheless, some areas that looked to Viking-era scientists like craters and volcanic areas were later shown to be riverbeds, lake bottoms, and ocean shorelines. If water once flowed on Mars' surface, where did it all go? This was the scene at NASA's Jet Propulsion Lab in 2004. The twin rovers Spirit and Opportunity had just bounced down on the red planet. When the excitement died down, the rovers were set off on one of the most remarkable journeys in the history of planetary exploration.